During this lesson you will be required to fill out a worksheet. I recommend you read through the worksheet before viewing the lesson. In order to give you time to do this, you can use the pause button at the bottom of the screen. Learning outcomes. By the end of this lesson you should be able to state the steps to be taken when connecting a new drain to an existing one. List what files the following pipes should be laid at: 100mm, 150mm and 225mm diameter. State what precautions should be taken when it is necessary for pipes to pass through a wall. And describe where haunching is used with the aid of a sketch. Connecting a new drain to an existing one. Saddle junctions can be used for this. The saddle should enter the main drain not from above but from the top side to avoid deposits building up in the main drain. The junction should be oblique, therefore less than 45 degrees, and should go with the flow of the main drain. Steps taken. A hole is cut mechanically, usually with an angle grinder, in the existing drain and cleaned for good adhesion. The saddle is placed in position and bedded in neat cement for a rigid pipe, remembering to keep the angle between the two pipes oblique if possible. When using newer PVC saddles, these are lubricated and pushed into position. The whole junction is then encased in concrete for protection. There are two forms of branch junction: oblique 45 degrees or square 90 degrees. Note the angle on the square connection is softened with a slight curve to the branch. Procedure for connecting to an existing pipeline using a branch junction. So working from the left to the right hand side here, step 1 is we excavate down to the existing pipeline and then bring all of our new pipes down to the location where we want to enter the existing pipeline. Step 2. Only when we have all of our new pipes ready to connect to the main drain do we actually cut into the existing pipeline. Also, we have to make sure that the existing pipeline is not being used at the time when we're cutting into the pipe. So we cut into the existing pipeline, slide on 2 sliding couplings over either end of the pipe. Step 3 then, we get our new branch junction, clip it into place, and then slide our sliding couplings back over from the existing pipeline onto our new branch junction. Then we encase the entire thing in concrete for protection. Falls. Recommended falls for a 100mm diameter pipe are 1 in 40, for a 150mm diameter pipe is 1 in 60, and for a 225mm diameter pipe is 1 in 90. These are only a guide. Note: all pipes that pass through walls should be bridged over using concrete lintels and haunched in 150mm of concrete. Laying socketed clayware. Mortar or rigid joints on socketed clayware were once common with old salt glazed pipes. They are used for certain saddle connections on bends or other fittings and for connecting to an existing socketed system. The gap between the spigot and the socket is packed with a gaskin. It's a type of tarred rope. And the joint is then pointed all the way around with a 3-to-1 mortar fillet to make the angle of 45 degrees with the barrel of the spigot. The spigot is the one on the left hand side and the socket is the one on the right hand side. Remember, your spigot should always be pointing downstream. Modern socketed clayware pipes. Most modern socketed pipes use a nitrile or elastometric O-ring to seal the joint between socket and spigot. So we can see in the diagram down below, we have our spigot and our socket, and we have the O-ring joint on the socketed pipe. So these are newer type rigid pipes. The O-ring is stretched into the preformed groove on the spigot of the incoming pipe, as seen below. The end of the spigot and the O-ring are lubricated and gently forced into the socket. Again, the spigot should always be pointing downstream. So this is a quick and efficient jointing system, but it is essential that the socket is kept clean and free from dust, dirt, grit, etc. before the spigot is inserted. Otherwise, the integrity of the joint may be compromised. Laying plastic ware, which of course is the most common used now. So there's two types of jointing systems that we use for laying plastic ware. First is the ring seal, and the second is the solvent-weld. Ring seal is by far the most commonly used, with solvent-weld used most often on installations subject to higher than normal pressures, such as in a pumped sewage system. Ring seal system. The ring seal pipes rely on an elastometric O-ring built into the coupling or the socket that is compressed against the outer wall of the upstream pipe or fitting when jointed, giving a completely watertight joint. The joints are lubricated and the pipes brought together with gentle force. So we can see in the diagram down below, we have down the bottom we have the socket and the spigot type, or else we have the coupling type where we have plain ended pipes and we're using couplings to join them together. Either ways, these are the easiest and most common methods used now for lane drainage systems. Solvent-weld system. We can see it in the diagram down here. We have a spigot and socket scenario here. These rely on pipes, couplings and fittings being glued together by means of a special solvent. It's very important that these are glued correctly, as mentioned earlier on. These are usually used in systems that act under high pressure. Manufacturers' jointing instructions must be followed to the letter, and different products should never be mixed. Conclusion. Steps taken when connecting to an existing drain are: 1. Cut a hole in the existing drain and clean for good adhesion. 2. Place a saddle in position and keep the angle oblique, less than 45 degrees if possible, and with the flow of the main pipe. PVC saddles are lubricated and pushed into position. Rigid saddles are jointed with neat sand and cement. 4. The whole junction is then encased in concrete for protection. Falls for pipes. Recommended fall for 100mm diameter pipe is 1 in 40, for 150mm diameter is 1 in 60, and for 225mm diameter is 1 in 90. These are only recommended falls. Building regulations state that any pipe carrying waste and soil water has to be at a minimum of 1 in 60 fall, no matter what the diameter of the pipe is. Pipes that pass through walls should be bridged over using concrete lintels and haunched in 150mm of concrete for protection.